Alright, this is the lesson for 1.1, the video for lesson 1.1, and we're going to talk about some key terms here first, and that would be a linear equation and slope. An equation that forms a line that is graphed is a linear equation. Slope is the ratio of rise to run of a line. If you remember, slope is a part of a linear equation. We'll look at how we can create that as we go. So first of all, you would have been taught initially how to graph lines, and that would be with tables. So we would take a look at this and say, alright, we have an equation, y equals negative 3x plus 4, and we're going to use that information to create a table. Now this is an equation where you would plug a value in for x as an input, and you would get a value of y out. So that's what we'll do here. Now when you're graphing lines, it's pretty important to, for your own sake, is to have both negatives and positives on the table. So just out of symmetry, I'm going to put a negative 3, negative 2, negative 1, 0, 1, 2, and 3. And those will be the numbers. Sometimes when you plug in negatives, it can affect how the graph looks on certain functions. Okay, so this is the best way to approach it. So if we plug in these values, I'll do this for the first example. If we plug in a negative 3 for x, we would then simplify the right side, or evaluate this with a negative 3 in for x. Negative 3 times negative 3 is 9. We would add 4 to it, and then we would get 13. And that would go in the y position. Now that is a coordinate. Alright, now if you looked at this graph, I would be negative 3 up 13. Well, I'm off the graph there, so I can't really use that spot. If I were to plug a negative 2 in, I would get a 10 with the same process, except I would have a negative 2 right here. Okay. Now if I plugged in a negative 1, I would get 7. If I plug in a 0, I would get 4. If I plug in a 1, I would get a 1. A 2 would give me a negative 2, and a 3 would give me a negative 5. Now I can graph these. So at negative 2 we are at 10. At negative 1 we are at 7. At 0 we are at 4. 1 is 1. 2 is negative 2. And 3 is negative 5. I think I can draw a line here. Let's see. And we would go through those coordinates and we would have our line. And this is the initial way we would learn how to graph an equation, by using tables. If we take a look at this one, same scenario, but we have a fraction in the equation, so it's a little bit more involved. And if we were to plug something in, again, if I were to plug in both negatives and positives in order, I would go negative 3, negative 2, negative 1, 0, 1, 2, 3 again. And then if you were to plug that in, again we would have a situation like this. If I plug in a negative 3, I would have to multiply 2/3 times negative 3. 2/3 times negative 3, well, it's like negative 3 over 1. So I would get negative 6 over 3, top times top, bottom times bottom, minus 2. Negative 6 over 3 is negative 2. And we get negative 4. Now that one works out pretty well, but not all of these work out well when we have fractions in the equation. So if we plugged in negative 2, we would actually get negative 3 1/3, or 0.33 repeating. If we plug in negative 1, we get negative 2 2/3, which is 0.6 repeating. 0, we get negative 2. 1, we get negative 1 1/3, or 0.3 repeating. And plug a 2 in, we get a negative 2/3, or 0.6 repeating. And plug a 3 in, we get 0. So let's just graph the ones that are clearest to us. If we plug in negative 3, we get negative 4. So left 3, down 4. And again, that's pretty straightforward. Let's go to another one. You only need 2 points to graph a line, so 0, -2. And that would be enough, but since we have one more, let's go ahead and graph it. 3, 0 over 3, and do not go up or down any. So if we graph a line there, there is our line. Now this one is a special one. If you look at it closely, there's only one variable. So here we just have y. So no matter what we plug in for x, well, there's no x. No matter what happens, y is always going to be a -3. So that means, even though it's a silly thing to say, if I were to plug in a -3, which we can't because there's no variable, we would get a -3 out for y. If we plugged in a -2, which again is silly because we can't, there's no x variable, we get -3 again. So no matter what we plug in, we're always going to get a -3. So what would that look like on a graph? Well, let's just find the first one. If we look at x of -3, like I said, it makes no difference. The y is going to be -3. If I go at -2, my y is still going to be -3, and so on. In other words, if I look at a coordinate where I have to have a y value of -3, I can plug anything into that x position and I'm going to be on the line, as long as my y is always -3. So if you look at this, you're going to hopefully notice that you have what's called a horizontal line. Okay? Here is a similar situation, but it's just x. So if you follow the same line of thinking, no matter what we have for y, our x will always be 2. Okay, so where our y may change, our x will not. Now if you take what we had just mentioned in mind, here it says x is always 2, and if I were to just write down randomly a couple of coordinates where x has to be 2, and then let's say we plug in just anything for y. Let's plug a 0 in for y and a 1 in for y. And let's graph those two. So we have x is 2, y is 0, x is 2, y is 1. Notice the points are above each other. So what we've now created is a vertical line. So vertical lines have coordinates where the x values are all the same. Horizontal lines have coordinates where y values are all the same. So two unique types of lines. Alright, so let's talk about a familiar, hopefully a familiar formula, which is the slope formula. Now, it's officially y2 minus y1 over x2 minus x1. That's the official one, but order doesn't matter so long as you have the same order on top and bottom. So I could legally write y1 minus y2 over x1 minus x2. As long as you're going in the same order, top and bottom, you're fine. What this does is it allows you to find the slope of a line given coordinates. So if I just gave you these two coordinates without a graph, and we were going to use this formula, we would say arbitrarily that this is the first coordinate. So I'd say x1, y1, and the second one we'll just say is the second coordinate. So this would be x2, y2. Now all the slope formula does is find the difference of the y values and the difference of the x values, so we can see what rise and run will be. So if we go and say y1 minus y2 or y2 minus y1, alright, so let's take a difference in the y values first. So I'm going to go 4 minus 8, that's the y values, over 12 minus a -6. You have to incorporate the negative of the 6 as well as the subtraction. And 4 minus 8 is a -4. 12 minus a -6 is the same as addition, which gives us 18. That does reduce to -2/9. So we know the slope just by using the slope formula. You could graph it as well, but we'll get to that later. The next one, again, take the y's. I'm going to go 0 minus a negative 6, negative 1 minus negative 11. So on the top, minus and negative is the same as addition. So we have positive 6, negative 1 minus negative 11 is plus 11. So we get 10. And again, that reduces to 3/5. Now let's go to a graph and see if we can get the slope from that. Now this, given a graph, makes it a lot easier to find slope. And we're talking about rise over run. So if we have a point and we're going from one point to the next, rise is up and down. Even though it's rise implies up, rise does describe movement of going up or down. So if I go from this point to the bottom right hand corner, I want to go down, straight down. Sorry about that. Straight down to there. Then we're going to go right to there. So what is the movement that occurred in going down? So let's check how many units we went down. Excuse me. So we went down 1, 2, 3, 4, 5, 6, 7. Now if we went down, we're going to say negative 7. To the right we went 1, 2, 3, 4, 5, 6, 7. So to the right it's positive movement, so positive 7. So if we consider the description of slope as rise over run, the rise was negative 7 and the run was positive 7. And that reduces to negative 1. Over here there are no points. So what do you do if you have no dots? Well, we're looking for where our line goes through crosshairs. So if you look closely at this line here, we have a crosshair, our line going through a crosshair right there. The next one doesn't quite work. Next one, no. Looks like the next one is about there, where it actually goes through a crosshair on the graph. Those are actual coordinates that we're used to looking at where we don't have decimals. So if we use that, rise over run, again I'm going to start on the left and go to the right. I go up, 1, 2, 3, 4, 5 would take me to an even level with the next dot. And I would go over 1, 2, 3, 4, 5, 6, 7 to the right, and that's positive. So rise over run, rise was 5, run was 7, and we have 5/7. And that ends the video lesson for 1-1.